Okay, so here we're taking a look at some of the examples for factoring differences of perfect squares. So they're going to be giving us something like x squared minus 64 that we had here, and we're going to have to work backwards to get the x plus 8 and the x minus 8. So taking a look at our first example here, I need two binomials that are going to multiply up to x squared minus 100. Well, the only things I could multiply to get to an x squared has to be an x times an x. That's the only way I can get an x squared. Now, getting to 100, that would be 10 times 10, plus 10, minus 10. Same terms, different signs. And you can always go back through and double check, which is great about these because you can know you have the correct answer by doing x squared minus 10x plus 10x minus 100. Those cancel, and I checked that it matches. So I'm not going to make you check all of them, but it is worth knowing that you can make sure you have the correct answer. So example 2, same kind of process here. I've got x times x, because that's the only way to get to x squared. And now 169. What are we doing to 169? What did we do to 100 to get 10? And what you might have noticed is that we are square rooting 100 to get 10. We're square rooting 169 to get 13. Therefore, that would give us x plus 13 and x minus 13. And it does not matter if the plus comes first or the minus. So there's that. Okay, example 3, a little different. Same kind of process though, just an extra piece involved. This time, instead of multiplying up to just an x squared, I want to get a 4x squared. So what things can I multiply by itself to get 4? 2. 2x and 2x gives me 4x squared. And to get y squared, that has to be plus y minus y. Same terms, different signs. Example 4 here, same kind of process, just backwards really. The only way to get 64 by squaring something is 8 and 8. So 8 and 8. And to get to a y to the 6th, the only way to get up to a y to the 6th, or taking the square root of y to the 6th, gives you y to the 3rd. So 8 minus y to the 3rd and 8 plus y to the 3rd, because y to the 3rd times y to the 3rd gives me y to the 6th. Example 5. Getting a little bit more complicated here with a fraction, but no big deal. Still starting off with your two binomials. The only way to get to 144 is to multiply 12 by 12, because again, the square root of 144 is 12. And to get to y to the 4th, we did that. That's got to be y squared and y squared. I know my signs have to be different. Don't let that fraction throw you up. 1 over 100 would be just like getting 100. Multiplying by to get 100 is 10 times 10. So to get 1 over 100 would just be 1 over 10 times 1 over 10. Boom. Example 6. Don't forget, humans, that 1 is a perfect square. The square root of 1 is 1. 1 times 1 does give me 1, so do not dismiss this. This can be factored. X to the 4th is x squared minus 1 and x squared plus 1. Now here, this is a tricky one because we can actually go further. We can take that x squared minus 1 and actually turn that into x plus 1, x minus 1, carry down the x squared plus 1, because that one can't be factored, and we will talk about why this one can't be factored, in the next example.